So hey guys, this is Wanli. I'm from the Brevis team. We're a zero-knowledge coprocessor. I know it's a really new term, but you're going to get to know the meaning of it. So today I'm going to talk about one important piece that we feel is missing in DeFi, which is data utilization. So we're all very familiar with Web2 applications and how they're utilizing data to basically increase customer engagement, boost user loyalty, and maybe sometimes cross-selling products within the same brand or within the same company. And this has been the case for social media apps. This has been the case for many Web2 financial services as well. So for example, many banks and financial services will have personalized offers and discounts for users based on their budgeting and savings and spending habits. There are also loyalty programs from banks that would reward users based on how many products they are holding or how many products they are investing in. There is also gamification design around savings and investments, so that to encourage recurring deposits into certain investment products. So there are a lot of practices utilizing data, and these approaches are all working well for Web2 applications because we are still seeing them in various products. But if you look at Web3 applications or DeFi protocols more specifically, you'll notice that DeFi utilization is totally missing. There are no such approaches as mentioned before. And you may wonder, does it mean that Web3 app builders do not know the power of data and they're not trying to build data-driven features? The reason is actually technical, and it's twofold. The first limitation that we're seeing with blockchain applications is that they do not have the full historical data access. What does this mean? So if you look at Ethereum smart contracts, actually smart contracts only have accessibility to the most recent 256 blocks. So any older block hashes are pruned by Ethereum to optimize on resource usage or storage. This is by Ethereum design. And this would mean that smart contracts, in order for them to access any older data, they will have to directly do Merkle proofs of inclusion within the smart contracts. And it would be very gas consuming, very costly. And the second limitation that we're seeing is for data-driven features to work, they usually need to build very expressive logic that are responsive to dynamic data input. So in order to build that expressiveness in those logic, it will require a lot of computation once it's executed. If you're trying to host that amount of computation directly on-chain in smart contracts, it would mean a lot of gas as well. So in theory, basically this does not work because of the costs. And let's look at a specific example. So if you're trying to replicate a trader loyalty program on Web3 for Uniswap, let's say, you're trying to have a user verify through Uniswap that they have completed 10,000 trades in the past 30 days for a total volume of over $30 million, so that they're like a large VIP user and they can enjoy 50% off for all future trades. This sounds fantastic, right? And this sounds feasible for Web2 applications. But if we are trying to execute this verification directly in Uniswap contracts, it will actually cost 4 hours of on-chain computation time and 20,000 in gas fees if you are trying to have everything decentralized, trustless, and Ethereum-based. So you can see how infeasible such a feature would be if we're trying to build it on-chain. And there are some efforts, I would say, to work around these limitations. For example, for data access, we have off-chain oracles, we have external indexers that developers use to feed data into smart contracts. For expressive compute, we have centralized servers, sometimes validator sets and multi-sigs for the results to be generated and computed in a very cheap way off-chain, and the results can then be sent back on-chain for smart contracts to directly use. These are all efforts, but they are, like, I would say, suboptimal alternatives because one important risk they are faced with, which is centralization. Because you are using these external validation models or external consensus models, you're not relying solely on the consensus model of Ethereum. You are introducing new risk assumptions and security assumptions. That's why we feel like Ethereum needs a ZK coprocessor that would allow blockchain to focus on transactional computation, while the ZK coprocessor will then focus on data-rich and complex computation. The blockchain will offload computation tasks to the ZK coprocessor, which is doing very cheap and fast computation off-chain, and it will generate results and send it back on-chain for use. But the entire process, which is also the most important part here, is to not compromise the trust-free nature of blockchain by not introducing new consensus models. And that's why we built Brevis. The previous design principle is basically the core of Brevis, where we have built Brevis to run arbitrary computation on any historical on-chain data. This solves the data availability problem. And we also generate an easy-to-verify zero-knowledge proof for the computation result so that it can be verified on-chain. So in order to easily onboard developers to use ZK coprocessing, we built a programmable SDK in the language Go, and it allows customizable data access, it allows arbitrary computation logic, and most importantly, it also allows for cross-chain verifiability. So basically, you can query computation tasks from any chain supported. So how does it work in action? There are, from a high level, 3 important steps that developers will need to understand and utilize for ZK coprocessing to work for their protocol, for their data-driven features. The first step is read. Brevis allows smart contracts to read into the full history of blockchain. And in the data access module of our SDK, we allow developers to specify the types of data needed in their feature. And since we talked about a trader loyalty program, here basically this code snippet is trying to retrieve the user swap event on USDC and ETH trades from Uniswap v3. And once the types of data is specified, developers can then build an app circuit that runs the computation logic. The app circuit is a very underlying concept in zero-knowledge technologies, but it's also like the very abstract and hard to understand part. But to basically help developers focus on business logic design instead of understanding how circuits work, we have abstracted away how circuits are implemented through our SDK. So here in the compute step, developers can easily translate their existing code or script into ZK circuits. And basically, this code snippet example here is trying to sum up the volume of those swap events that we retrieved earlier to come up with a sum volume for a user address. And at the end of the last step, there will be 2 zero-knowledge proofs generated. The first zero-knowledge proof is to attest to the data sources, the validity of the swap events. So we are basically saying through the zero-knowledge proof, we can attest that the swap events for those trade volumes do exist in the history of blockchain. And the second zero-knowledge proof is to attest to the computation execution process. So we are basically saying the sum volume is generated in a correct way. It's calculated correctly, and it's verifiable. And the 2 zero-knowledge proofs are aggregated into one single zero-knowledge proof. And along with the result, the sum volume, they're pushed back on chain for the smart contracts for Brevis to verify the zero-knowledge proof. If the verification succeeds, then the sum volume is going to be sent to the Uniswap smart contract. And Uniswap is then able to determine, hey, this user is a VIP user, and they should enjoy 50% off going forward for all trades. So this is like basically the 3 important steps. And since Brevis supports multi-blockchain data access and verification, developers can basically build a very unified user experience across different blockchains. So this would mean that trustless data-driven DeFi is no longer some promising prospect, but something that we can build in production with real use cases. And one example is with Quanta. Quanta is a top derivatives trading platform on-chain with over 60 billion in transaction volume and close to 1 million in trades. And just last week, Quanta launched a new tiered VIP rebates program that uses Brevis to fetch and compute users' trading volume from on-chain. And they're going to rebate the users a percentage of the user's total trading fees before based on the specific tier the user belongs to. So how this works from a high level is that Brevis services on an everyday basis will, from an off-chain, will retrieve and prove user transactions. This is data access and data availability. Based on the data retrieved, Brevis is going to compute the 30-day trading volume and fees of all of the available user addresses. And once the computation is complete, Brevis is going to send the results, the volume and fees, as well as a zero-knowledge proof back on chain for the Brevis contract to verify. If the ZKP succeeds the verification, then the Brevis contract is going to send the result to the Quanta contracts. And when a user tries to claim their rebates, essentially Quanta will then be able to tell what tier the user belongs to and rebates the user based on their tier, a percentage of their total fees. We're also in talk with yield aggregators that are trying to build trustless strategy automation. So how Brevis works for this design is Brevis will collect on-chain data for different pools, vaults, basically different opportunities and positions, and then do the calculation or computation off-chain in the Brevis services based on the developer's specified logic. And Brevis is then going to be pushing the data, the yield data, back on-chain for ZK verification and store the data in the rebalancer contracts, the yield aggregator contracts. And the yield aggregator then will be able to automatically trigger rebalances of liquidity for users to maximize their yields. And we're working with V4 DEXs because we mentioned yield aggregators, we mentioned derivatives. Now it comes to one large player in the DeFi space, which are DEXs. So we have worked with the Uniswap Foundation and launched a demo to allow users to verify through Uniswap their past trading volume and claim a VIP tier, and according to the VIP tier, they could then trade with a discount going forward. So this is one example of how dynamic fees can be implemented using Brevis, but actually dynamic fees are not limited to only like trading volume-based fees. You can also build dynamic fees based on, for example, volatility of the market, the token price changes. You can also build even dynamic fees based on the token holdings of user addresses. DEXs can also build dynamic LP rewards to encourage like stable LP positions when faced with volatile market conditions, because like those are the liquidity most needed in those conditions. So in order to achieve that, there are some DEXs that we are working with that are building rewards based on time-weighted LP shares. But you can basically see the formula here. As long as a developer, you can specify the types of data you need through Brevis, and you can translate your existing business logic into ZK circuit easily using the Brevis SDK. It can be aggregation, it can be trying to find the maximum volume, minimum amount of certain transactions. Then you'll be able to drive your features, drive your dApps through dynamic data input. So yeah, there are many interesting and powerful use cases and opportunities out there. If you have any ideas, feel free to follow us on Brevis. We are like constantly launching great news and happy to have a chat afterwards too. Thank you.
That's super interesting. I actually have a question for you, if you don't mind. Previously in a DeFi protocol I was running, a big problem that we had was not being able to understand who we're selling to, high-value customers. We ran a Galaxy campaign that with X DeFi wallet that reported 200,000 users, and when we checked the on-chain data, it was 8, which we found very crazy. But outside, I guess, dynamic fees and dynamic rewards, what are you sort of most excited about for leveraging on-chain data?
Yeah, I think the use case you mentioned is also one of the important explorations we're having, because working with Galaxy, not saying their user experience is bad, but still they're faced with centralization issues, meaning like the data you're getting might not be accurate, and you may rely on some third party telling you that this list of users are actually the solid users who should get the rewards. But if you're having a way to basically have smart contracts verify directly that the user trace their transactions are solidly verifiable on chain, the challenge would be resolved. So like I think the experience, the user experience part of Galaxy is something we can reference, and we can even work with them to maybe like move their centralized portion into ZK verifiable portions. So, but like I think user engagement, user segmentation, and rewarding users based on their past footprints on chain is also one vertical we're going with.